Hi, welcome to the first lecture on Arduino. Let us see what is a robot and how to interface the elements of the robot, suppose sensors, and how to achieve a complete automation of a robot. Here, let us consider I have a robot. For example, this is my robot. So, in order to perform any action or in order to rotate any load, suppose, for example, consider uh, this is the load circuit that we are going to consider, and my requirement is to operate this particular load by this robot. Okay, this is my application. So, this requires first one is we need to take input from the external environment, that is from the user, and second thing is we need to process the information by using a microcontroller within the robot, and third we need to provide output to the load. These three are the basic things uh, which we need to consider while designing any robot. Okay, so here we can have, yeah, these inputs can be taken by using sensors. There are various types of sensors available in the market, and this process or this automation can be done by using automation or control can be done by using a microcontroller such as 8051 or AVR series, etc. So, and this output is nothing but any motor, for example any servo motor, or DC motor, or any servo motor, etc. So these are the basic requirements that we need for to construct a robot, so let us take some of the examples in real-time examples. For example, I have an application to control a DC motor. How to control this DC motor? So, for example, we need to first design this system by using mainly three blocks. First one is the controlling system, which controls that particular DC motor. For example, this is the DC motor which I need to control, and this is nothing but the load, and this is the control element, and we need to take input from any source. This is the complete block diagram to control DC motor. Let us go in detail about these. First one is the input that we are going to consider. What type of input? Majorly, in any type of input will be in the form of analog. Each and every signal in the nature is analog signal. So we need to take analog inputs from the external world, and we need to process this analog input, and we need to output the result obtained from this process. So, how to get this analog input is the main question. How to get this? How to get this signal? So this can be done by using a sensor. For example, what does sensor means? Any external input signal, any external physical quantity, external physical quantity is going to be converted into electrical signal, and that electrical signal is used to process the information. So here there comes another block, that is this is the sensor, this is the input signal what I am giving, This is the output signal from the sensor, which is the electrical signal, and this electrical signal, which is in the analog form, is given to a ADC converter, and this ADC converter is given to the controlling element. This is the process, and this controlling element produces corresponding outputs to drive the load. That's the basic block diagram for any system, any controlling system that we need to use in real-time applications. Okay, next our main question is, and our main task is to design any microcontroller or to interface these inputs, interfacing these inputs, controller and outputs. This is the main task in front of us. So in these lectures, in this following lectures, I want to discuss about only this controller. Let us leave these inputs and leave those outputs for some time, and let us discuss about this controller. So nothing but it's a controller, nothing but it will be it may be a size of a room, or it can be a size of it may be a very large size, but here in robotics and in some electronic control applications, we mostly use a microcontroller. What is a microcontroller? Basically, it's nothing but a microprocessor. It's nothing but a computer. A microcontroller is nothing but a small computer which is embedded on a single chip. There are various different types of microcontrollers available in the market. For example, Atmega 8, Atmega 16, etc. We can find various brands of microcontrollers in the market. So we need to confine our discussion about a single microcontroller or the microcontroller board, which is known as Arduino. In the corresponding following lectures, we will only discuss about this Arduino, the significance of Arduino, and the hardware implementation, how the hardware architecture of Arduino is made, and how we are going to write the code in Arduino IDE, Arduino integrated development environment. And later we are going to construct a robot by using this basics of Arduino. What makes the difference between Arduino and AVR microcontrollers and all is we are going to use a high level language that is in the Arduino IDE in order to write a code in the Arduino microcontroller, and this high level language is very simple and easy to code. For it is really understandable easily to any type of user to write a code in Arduino, and this will be very useful for to develop any real-time application by using very less equipment and also less cost of sensors, and then the coding is very easy in this particular Arduino. It is a open source. You can download it from you can download the software from www.arduino.cc. Is a open source software that is available in the market. You can just download it and you can run this application. And we need the basic requirements for this Arduino is we need Arduino board, which is the hardware, and Arduino IDE, which is in which we are going to write our programs, and yeah, these two things we need these two things in order to learn basics about Arduino coding. And later we will develop how to construct a robot by by using this Arduino microcontroller. And later on we are going to construct a robot for various applications, such as line followers, obstacle detectors, and all the other stuff. Thank you.